Florida International University, Miami, Florida, USA. He is also the Satish Dhawan Chair Professor at the University of Science, Bangalore. S Sitarama He was born on August 26, 1947 in MBA, a village along the side of Kaveri River, situated about 7 kilometers from Sripur. ಯಾವ ಕಂಡೀಷನ್ ನೋಡಿ ಹಳ್ಳಿಯಿಂದ ಬಂದು ಹಳ್ಳಿ ಕಂಡೀಷನ್ ಆಕ್ಚುಲಿ ಅವರು ಇದೆಲ್ಲ ಅವರು ಇದರಲ್ಲಿ ಸಿಕ್ಕತ್ತೆ ಬಯೋಗ್ರಫಿ ರಾಮಕೃಷ್ಣ ಅವರಲ್ಲಿ ಮೀಟ್ ಮಾಡಿರೋದಾಗ ಅದು ಎಲ್ಲ ಸಿಕ್ಕತ್ತೆ ಅವ್ರು ಯಾವ ಬರ್ತನ ಬಂದಿದ್ದಾರೆ ಯಾವ ರೀತಿ ನ್ಯಾಷನಲ್ ಕಾಲೇಜ್ ಬಂದು ಮುಂದೆ ಫೇಮಸ್ ಆಗೋಗ್ತಾರೆ. ಅಪಾರ್ಟ್ ಫ್ರಮ್ ದಟ್ ಯು ಆರ್ ಗ್ರಾಜುಯೇಟೆಡ್ ಫ್ರಮ್ UBC Bangalore University India, the BS in Engineering in 1968, University of Science in Bangalore with MS in M Engineering in 1970 and received a PhD degree in 1974 from Mississippi State University. Has been a PI/co-PI on many NSF, DRPA and MURI funded projects and has been an active participant in numerous government sponsored studies. ಈ ದೇಶದಾಗೆಲ್ಲ ಅಮೆರಿಕಲ್ಲಿ ಬದುಕಬೇಕಾದ್ರೆ ಆ ಯೂನಿವರ್ಸಿಟಿ ಫಂಡಿಂಗ್ ತರಬೇಕು, ಪ್ರಾಜೆಕ್ಟ್ ತರಬೇಕು. ಅದೆಲ್ಲ ಹಾಕಿದ್ರೆ ಮಿಲಿಯನ್ಸ್ ರುಪೀಸ್ ಆಕ್ಚುಲಿ ನಾಟ್ 1 or 2 rupees. He has chaired many international conferences on distributed sensor networks and served on many programming committees on sensor networks around the world. ಕೆಲವರು ಅರ್ಥವಾಗುತ್ತೆ ನಾರ್ಮಲ್ ಪ್ರಶ್ನೆ ಈ ಸುನಾಮಿ ಎಲ್ಲ ಬಂದಿತ್ತಲ್ಲ ಅದಕ್ಕೆ ಸಂಬಂಧಿಸಿದೆ ಚೆನ್ನಾಗಿ. Dr. Iyengar has published over 400 research papers in journals and conferences and has co-authored and edited 14 texts in the areas of parallel algorithms, sensor networks, wavelets, robotics and computer modeling of complex biological systems. The pure computer science ಹೋಗಿ ಅಪ್ಲೈಡ್ ಹೋಗಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಹೋಗಿ ಬಯಾಲಜಿ ಹೋಗಿ ಫಿಸಿಕ್ಸ್ ಹೋಗಿ ಎಲ್ಲ ಕಡೆ ಇದೆ ಟೋಟಲ್ ಬಂದಾಗ. He has won many best paper awards sponsored by international conferences and research publication on data structures, robotics, parallel computing and sensor networks. ಯಾವ ಕ್ಲಾಸ್ ಹೋಗ್ಕೊಳ್ಳಿ, ಯಾವ ಎಕ್ಸಾಮ್ ಹೋಗ್ಕೊಳ್ಳಿ, ಯಾವ ರಿಸರ್ಚ್ ಪೇಪರ್ ಕಾನ್ಫರೆನ್ಸ್ ಹೋಗ್ಕೊಳ್ಳಿ, ಅವ್ರಿಗೆ ಏನಿಲ್ಲ ಅವ್ರು ಕೊಟ್ಟಿದ್ದೇ ಬೆಸ್ಟ್ ಪೇಪರ್ ಆಗುತ್ತೆ, ಬೆಸ್ಟ್ ಅವಾರ್ಡ್ಸ್ ಸಿಗುತ್ತೆ ಟೋಟಲ್ ಆಗಿ. And has graduated over 42 PhD students, 42 members and large number of postdoctoral from various institutions in the world. Iyengar also founded and directs robotic research laboratory at Louisiana State University. He has been a visiting professor, a scientist at Oak Ridge National Laboratory, Jet Propulsion Laboratory, Naval Research Laboratory, and has been awarded the Satish Dhawan Distinct Chair Professorship at the University of Science, the Homeopathy Distinct Chair Professor, IITCR, and a professorship at the University of Paris. ಇದೆಲ್ಲ ಪ್ರಪಂಚ ನಮ್ಮದು ಆ್ಯಕ್ಚುಲಾಗಿ. ಆಮೇಲೆ ಇವಾಗ ಲೇಟೆಸ್ಟ್ ಪೇಪರ್ ನಮ್ಗೆ ತೋರಿಸಿದ್ರು ಮೆಷಿನ್ ಟು ಮೆಷಿನ್ ಅಂತ ಟೆಕ್ನಿಕಲ್ ಆಗಿ. ಈಗ ನಾರ್ಮಲ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಬರುತ್ತೆ ಇಂಟರ್ನೆಟ್ ಆಫ್ ಥಿಂಗ್ಸ್ ಅಂತೇಳಿ ಅದು ತೈವಾನ್ ಯೂನಿವರ್ಸಿಟಿ ಸರ್ ಏನು ಬರುತ್ತದೆ IEEE ಪ್ರೊಸೀಡಿಂಗ್ಸ್ನಲ್ಲಿ. Professor Iyengar is a member of the European Academy of Sciences, a fellow of the Institution of Electrical and Electronics Engineers. ಸೊ ನಿಧಾನ ಹೇಳ್ತೀನಿ ನಾಲ್ಕು fellow of IEEE ಬೇಕು ಗೊತ್ತಾಗ್ತದೆ ನಿಮಗೆ. A fellow of Association for Computing Machinery, ACM. A fellow of the American Association for the Advancement of Sciences, AAAS, and fellow of the Society for Design and Process Science, SDPS. In the statement, IEEE, ACM, CAS, SDPS. ಸಂತೋಷ ಪಡ್ತಾರೆ ಕೆಲವೊಂದು ಕಡೆ ಪೂರ್ತಿ ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ, ಪೂರ್ತಿ ಗೊತ್ತಾಗುತ್ತೆ ನೋಡಿ. ಅಮೇರಿಕನ್ ಅಸೋಸಿಯೇಷನ್ ಫಾರ್ ದ ಅಡ್ವಾನ್ಸ್ಮೆಂಟ್ ಆಫ್ ಸೈನ್ಸ್ ಬರುವಂತ ತಕ್ಷಣನೇ ಸರಿಯಾಗಿ ಬುದ್ಧಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ. ಸಾಮಾನ್ಯವಾಗಿ ನೋಬೆಲ್ ಪ್ರೈಸ್ ಬಂದವರು ಮಾತ್ರ ಕೊಡೋದು ಫೆಲೋಶಿಪ್. ಅದೇ ಫಿಸಿಕ್ಸ್, ಕೆಮಿಸ್ಟ್ರಿ, ಬಾಯಲ್ಲಿ ನೋಬೆಲ್ ಪ್ರೈಸ್ ಬರುತ್ತೆ, ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ ಬರಲ್ಲ. ಆಗ PhD ವರ್ಕ್ ಮಾಡಿ ಅಂತ ಕೊಡ್ತಾರೆ. ಇನ್ಫ್ಯಾಕ್ಟ್ ಆ ದೇಶದಲ್ಲಿ ನಾವು ಫಿಸಿಕ್ಸ್ನವ್ರಿಗೆ AA ಸಿಕ್ಕಿದೆ ಆಲ್ಮೋಸ್ಟ್ ನೋಬೆಲ್ ಪ್ರೈಸ್ ಅಂತ ಆರ್ಗನೈಸೇಷನ್ ಅದು. IEEE ಬೇಕಾದ ಮಾಡುತ್ತೆ. ಆಮೇಲೆ ACM ಅಂತಕ್ಕಂಥ ವೆರಿ ಟಾಪ್ ಒನ್. ಇಫ್ ಐ ಆಮ್ ಕರೆಕ್ಟ್, ನೀವು ನ್ಯಾಷನಲ್ ಲೆಕ್ಚರ್ ACM ನಮ್ಮ ನ್ಯಾಷನಲ್ ಪ್ರೊಫೆಸರ್ ಬೇಕಾದ್ರೆ ಇಂಡಿಯಾಲಿ ಆ ಟೈಪ್ ನ್ಯಾಷನಲ್ ಲೆಕ್ಚರ್. ಈ 3 ಸೆಂಟರ್ಸ್ ನಲ್ಲಿ ಅವ್ರ ಎಂಟೈರ್ ಲೈಫ್ ಆಗಿದೆ ಅಥವಾ ಸಮಥಿಂಗ್ ವೆರಿ ಗ್ರೇಟ್. ಅಥವಾ ಏನೋ ನಿಗೇಶಿ ನಾಲ್ಕಾಗ್ತಾ ಇಲ್ಲ, 1% ಆದ ಬಿಟ್ರೆ ಈ 3AS ಅಮೇರಿಕನ್ ಅಸೋಸಿಯೇಷನ್ ಅಡ್ವಾನ್ಸ್ಮೆಂಟ್ ಸೈನ್ಸ್ ಅಲ್ಲಿ ಫೆಲೋ ಫಸ್ಟ್ ಪರ್ಸನ್ ಬರ್ತಾರೆ. ವೆರಿ ಪ್ರೌಡ್ ಆಫ್ ಇಟ್. ಅಂತ ಕಷ್ಟಪಟ್ಟು ಎಷ್ಟು ಕಷ್ಟಪಡ್ತಾರೆ, ಎಷ್ಟು ಟೈಮ್ ತಗೊಂಡ್ರೆ, ಎಷ್ಟು ದುಡ್ಡು ಖರ್ಚು ಮಾಡೋದೆಲ್ಲ ಮಾಡ್ತಾರೆ. ನಾವು ಏನು ಮಾಡ್ಕಂತ ಶುಗರ್ಲೆಸ್ ಆಗಬೇಕಪ್ಪ ಕಾಫಿ ಬಿಟ್ಬೋದು, ಆಮೇಲೆ ಶುಗರ್ ಬೇಕಪ್ಪ ಕೊಟ್ಟಿದ್ವಿ ನಾಟಕ ಒನ್ ಆ್ಯಪ್ ಅದರಲ್ಲಿ ಅವ್ರಿಗೆ ಎಷ್ಟು ಜಾಲಿ ಪರ್ಸೆಂಟ್ ಹೇಳ್ತಾರೆ. ಯಾವ ಬರ್ತಾರೆ ಸರ್ ಫೆಬ್ರವರಿ ಹೊಡ್ತಾ ಇಲ್ವೋ, ನೀ ಏನೇ ಮಾಡ್ಕೋಬ ಜುಲೈ 1 ಜುಲೈ 30 ಬಂದ್ಬಿಡ್ತೀನಿ I think 10th year number 10th. You understand Prabhu Naga director. ಅದು ಏನು ಬೇಕಾದ್ರೆ ಹಾಕೊಳ್ಳಿ ಬರ್ತೀವಿ ಅಂತಾರೆ. ಹಾಗೆ ನನಗೆ ಕ್ಲೋಸ್ ಹಾಕೊಂಡು ಅವ್ರ ಬ್ಯಾಗ್ ಹೊಸಬೇಕಾದನ್ನ ಅವ್ರು ಏನು ಹೇಳಿದ್ರು ಅಂದ್ರೆ when you come to Paris straight away come to my room ನೆನಪಟ್ಬಿಡೆ come to room ಬಟ್ ನೀನು ಏನೋ ಬೇಕಾದ್ರೆ ನಾನು ಹೇಳೋ ಬರ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ರು. ಬಟ್ ನಾನು ಅವ್ರು ಯಾಕೆ ಹೇಳಕ್ಕಾಗಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಸುಮ್ಮನೆ ಬಂದ್ಬಿಡು ನಮ್ಗೆ ಎದುರು ಕೊಡಕ್ಕಾಗಬೇಕಲ್ಲ ಕೊಟ್ಟದಾಗೆ these are some problems actually. Dr. Iyengar won the Distinguished Alumnus Award of the Indian Institute of Science. Such a great placement. And he was awarded the IEEE Computer Society's Technical Achievement Award and IEEE Golden Core member, the very fellow Golden Core member. Professor Iyengar is an IEEE Distinguished Visitor. Visitor is not much more than a profession. And SAM Distinguished Lecturer or even to ACM National Lecturer. That's interesting. He has also been awarded Honorary Doctorate of Science and Engineering from institutions around the world. Of course, unfortunately, our university has several actually. He serves on the advisory board of many corporations and universities. Dr. Iyengar received Distinguished Faculty Research Award from Department of Navy, Naval and Laboratories Tennis Space Center MS. Actually, our shift ಮಾಡಿದ್ದೇನೆ ಸ್ಪೇಸ್ ಸೆಂಟರ್ ಜೊತೆ ವರ್ಕ್ ಮಾಡೋಕ್ಕೋಸ್ಕರ ಫ್ಲಾರಿಡಾ ಸ್ಟೈಲ್ ಮಾಡೋದು. ಇವ್ರಿಗೆ ಎಲ್ಲ ಒಂದು ಡೈರೆಕ್ಷನ್ ಇನ್ನೊಂದು ಡೈರೆಕ್ಷನ್ ಕೊಟ್ಟೋಗಿ ಅದು ನೋಡಿದಾಗ ನನಗಂತೂ ತುಂಬ ಸಂತೋಷ ಪಡ್ತದೆ. ಒಂದೇ ಅಂತ ಹೇಳಿದ್ರೆ ನಮ್ಮ ಕಾಲೇಜ್ ಸ್ಟೂಡೆಂಟು, ಇನ್ನೊಂದು ಏನು ಹೇಳಿದ್ರೆ ನಾನು ಇವಾಗ ಬದುಕಿರ್ಬೇಕಾದ್ರೆ ಇಂಥ ನೋಡ್ತಾ ಇದ್ದಿಲ್ಲ ಅಂತ ಆ್ಯಕ್ಚುಲಾಗಿ ಸಿಗೋದೇ ಕಷ್ಟ ಆಯ್ತು. ಅದಲ್ಲದೆ ನೆಕ್ಸ್ಟ್ ಬರ್ತಾ ಇರೋದು ನಾವು ನ್ಯಾಷನಲ್ ಕಾಲೇಜ್ ಏನಪ್ಪ ಮಾಡೋಣ ಅಂತ ಹೇಳಿ ಐ ಥಿಂಕ್ ಸ್ಲೈಟ್ ಅದರಲ್ಲಿ ಇನ್ನೊಂದು ಹೇಳ್ಬೇಕಾಯ್ತು ಮಾಡ್ಬಿಟ್ಟೆ. ಈ ಸಾಂಗ್ ಅಂಡ್ Iyengar Mobicom ಒಂದು ಮಿಡ್ಲ್ವೇರ್ ಕಂಪ್ಯೂಟಿಂಗ್ ಪ್ಲಾಟ್ಫಾರ್ಮ್, ಬ್ಲೂ Iyengar ನ್ಯೂ ಡಿಟೆಕ್ಷನ್ ಅಲ್ಗಾರಿದಮ್, ಎಷ್ಟೊಂದು ಗೊತ್ತಿಲ್ಲ ಹೆಸರಿದೆ, ಆಲ್ ಟಾಪ್ ಕ್ಲಾಸ್. ಅದಲ್ಲದೆ ನ್ಯಾಷನಲ್ ಕಾಲೇಜ್ ಏನೋ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ವಿ ನೀಡ್ ಹೆಲ್ಪ್ ಆಫ್ ಆಲ್ ದಿ ಪೀಪಲ್. ಇವಾಗ ಇಂಡಿಯಾದಲ್ಲಿ ಹೌ ಮೆನಿ ನೋಬಲ್ ಲಾರೀಸ್ ಆರ್ ದೇರ್ ಅಂತ ಹೇಳಿದ್ರೆ ನಾನು ಓನ್ಲಿ 2 ಅಂತ ಹೇಳ್ತೀನಿ. ಇಂಗ್ಲೀಷ್ ಹೇಳ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇನ್ನೊಬ್ಬ 4 ಅಂತ ಹೇಳ್ತಾನೆ, ಇನ್ನೊಬ್ಬ 6 ಅಂತ ಹೇಳ್ತಾನೆ. ಎಲ್ಲ ಸೇರಿಸ್ಕೊಂಡು 10 ಓವರ್ ಆಗ್ತಾನಂತಲ್ವೇ. ನಾನು 2 ಯಾಕೆ ಅಂದ್ರೆ ಇಂಡಿಯನ್ ಬಾರನ್ನು ಅಂದ್ರೆ ಇಂಡಿಯನ್ ಸಿಟಿಸನ್ಶಿಪ್, ಇನ್ನು 4-5 ಜನ ಬೇರೆ ಬೇರೆ ಸಿಟಿಸನ್ಶಿಪ್ ಇದ್ದಿದ್ದು. ಇದೆಲ್ಲ ಸೇರಿಸ್ಕೊಂಡ್ರು ಅದ ನಮ್ಮ ಹೆಸರುನೆಲ್ಲ ಸೇರಿಸ್ಕೊಂಡ್ರು ರಾಮಕೃಷ್ಣ ಅಂತ ಅರ್ಥಾಗೋದಿಲ್ಲ. ಅಮೆರಿಕಾದಲ್ಲಿ ಈ ಕ್ವಶನೇ ಇರಲೆಂಟು, ಯಾಕಂದ್ರೆ 200-300 ಜನ ನೋಬಲ್ ಆರಿಸಿದ್ದಾರೆ. ಅಂಡ್ ಆಲ್ ಆಫ್ ದೆಮ್ when they were young 16-17 years were science talent scholars of Intel Corporation Westinghouse model. ಎಷ್ಟು ಚೆನ್ನಾಗಿ ಸೈನ್ಸ್ ಎನ್ಕರೇಜ್ ಮಾಡೋದು. 14 ವರ್ಷ ಆದಾಗ ಈತನ ಹಿಡಿದುಬಿಟ್ಟು ಇಸ್ ಅ ಗ್ರೇಟ್ ಸ್ಕಾಲರ್ ಅಂತ ಎನ್ಕರೇಜ್ ಮಾಡೋದು. ಅವನ ಲೇಟೆಸ್ಟ್ 40-50 ಬಂದ ನೋಡ್ಬೇಕು ಕೂಡ ಅವರು 380% ಇದೆ. ಆ ಮಾಡಲ್ ಇದು ಮನಸ್ಸಿನ ಇದೆ ನೋಡಪ್ಪ, ಕೂತ್ಕೊಂಡು ನಾವು ಇಂಡಿಯಾ ಕರ್ನಾಟಕ ವರ್ಕ್ ಮಾಡೋಣ. ಮೇ ಬಿ ಟುಡೇ ಇಫ್ ಯು ವರ್ಕ್ ಆಫ್ಟರ್ 20 years ಯು ಮೇ ಸಿ 1 or 2 ನೋಬಲ್ ಲಾರೀಸ್ ಅಂತ ಕೊಡ್ತಾರೆ. ಎಂಥ ವಿಷನ್ He is ready to spend all the time for that. ಅದಲ್ಲದೆ ನಮ್ಮ ದೇಶದಲ್ಲದೆ ಯಾರು ಬೇಕಾ ಇವಾಗ when there is an internet, there are people very ideal and ಗೊತ್ತಿದ್ದಾಗೆ. If they are interested to do some research work in any field of computer science, let them meet me. I am prepared to become a guide for them ಅಂತ ಹೇಳ್ತಾರೆ. ಇದು 3 ಪೇಜ್ ನಾನು ಓದ್ದೇ ಇಲ್ಲ ಆ್ಯಕ್ಚುಲಾಗಿ, ಎಷ್ಟು ಹೋಗುತ್ತೆ ಅಂತ. ಬಟ್ ಆ ಬಯೋಟ 200 ಪೇಜ್ ಇದೆ. ನಾನು ಆ ಬಯೋಟ ಇಲ್ಲಿ ಮಾಡಕ್ಕೆ ಹೋದ್ರೆ ಒಂದಿನ ಅವಳ ಹೆಸರಲ್ಲೇ ಸೆಂಡ್ ಮಾಡ್ಬೇಕಾದ್ರೆ 8 hours ಬೇಕಾಗುತ್ತೆ, ಕೊನೆಗೆ ಅವ್ರು ಮಾತಾಡ್ಬೇಕಾಗುತ್ತೆ. ಬಟ್ ಇವತ್ತು ನಮ್ಗೆ ಅವ್ರ ಮಾತು ಇಂಪಾರ್ಟೆಂಟು. ದೇಫೋರ್ ಸಂವೇರ್ ಆಗ್ಬಿಟ್ಟಿಗೆ ಫುಲ್ ಸ್ಟಾಪ್ ನೋಡಿ ಎಷ್ಟು ಅಚೀವ್ಮೆಂಟ್ಸ್ ಮಾಡೋರಿಗೆ ನಾನು ಹೇಳೋಕ್ಕೆ ಟೈಮ್ ಇಲ್ಲ ಆ್ಯಕ್ಚುಲಾಗಿ. ಎಲ್ಲೋ ಒಂಚೂರು ತೊಗೊಂಡು ಹೇಳಿದ್ದೀನಿ, ಅದೇ ಭಾಳ ಪ್ಲೀಸಿಂಗ್ ಆಗಿದೆ, ಅದೇ ಎನ್ಕರೇಜಿಂಗ್ ಆಗಿದೆ, ಹುಡುಗರಿಗೆ ಅದೇ ಆದರ್ಶವಾಗಿದೆ ಆ್ಯಕ್ಚುಲಾಗಿ. ವಿತ್ ದೀಸ್ ಫ್ಯೂ ಇಂಟ್ರಡಕ್ಷನ್ಸ್ ಟುಡೇ ಐ ವೆಲ್ಕಮ್ ಅಗೈನ್ ಡಾಕ್ಟರ್ S Sitarama Iyengar and request him to continue with that.
Thank you. Professor Ramrao, thank you very much for wonderful introduction.
ಮುಂದ್ಗಡೆ ಇರೋ ದೀಪ ಮಾತ್ರ ಆರಿಸಕ್ಕಾಗುತ್ತೆ. ಮುಂದ್ಗಡೆ ಇರೋದು ಮಾತ್ರ.
So you know what I'm going to do? I'm going to start off with a very nice story. How the National College has played such significant role, not just for me, for our family, but for lots of students all around the world. So I'm going to start with a very small, quick note, and then there is also everything I'm going to talk today is all related to big data. But this is a very interesting story. The reason I just thought about it is somewhat very critical, because there are so many youngsters, outstanding people here, and this can certainly play a very wonderful role in the context of developing certain amount of motivation for my talk. Okay, so let's do that. And so this is where our university is located, a very beautiful place. If you have been to Miami, maybe some of you may have been. A very wonderful place. A lot of interesting things that one can work on. So I'll give you this story. This is something very important, very close to my heart also. Now, you see that he is Dr. Iyengar. I want to tell you a little story. In 1993, or 93, he was visiting India. He was about to join, MIT. Of course, he's my son, but I will tell you a little more interesting things what has happened in the last 25 years. So he graduated from MIT, and then, so when he came in 1993, Indian Express interviewed him. So when they came and they came to our house, and they said, this I'm talking in 1993, and there was a story that was written by Indian on the very front page of the Indian Express. So they said, what do you want to do in your life? So he said very firmly, I would like to find some cure for cancer. Okay? So, he was only about 18 or 19 years old, with a very strong word, firmness. I would like to find some type of a cure, and that's what I'm interested in. And so remember, he was not even a doctor at that time. So there was a very beautiful story. It came. So, and then when the story appeared, right in the afternoon, Professor H. Iyengar called and said, in that they had written that he's, son of Dr. Iyengar, he was a student at National College. Then, Professor H. said, no, you should bring him immediately to come and give a talk. So then he came here, and I don't know how many of you remember, but this is quite some time back. He came and gave a very beautiful talk, and a very general talk, what his motivations are. So now, just last week, so he, of course now this is the way he looks, he's about 40 years, 39 old, and he has been able to discover, a kind of a gene that causes cancer, especially for lung cancer. So there was a big story all around United States, and it was on newspaper, everything. So this is actually the one which you can see on the cover page of the major newspaper, as well as his University of Texas Medical School. That's where he's a professor. So he said, that this kind of a innovation has helped many lung cancer patients, and they've been able to live. And they did a lot of clinical data, and they came up with some sort of an isolation of a gene, and then they were able to sort of find. So this is the beginning of a long journey. So what is that it actually tells us? And I'm very proud to say that, his passion, commitment plus delivery, it's all what I call as excellence. So you remember in 1993, when he said that he wants to do something, so in the last 20 years, he is really in that area. Unfortunately, he has been into, with many good community and doctors and research, so he's been able to. So now, people are hoping, that he might get a Nobel Prize maybe in the next 10 years. So if this is the way it continues, because the Nobel Prize is a very important achievement for anybody, and of course he still has a long way to go, but this is an excellent. So he spends 10 to 14, 12 hours every day in the lab trying to see. Now, if you look at it, a lot of the training he got at MIT by a professor by name Hargobind Khorana, right here, who was also a Nobel Prize winner at MIT. He did some things related to genome sequences. So the training and the environment and the passion and excellence, so all this started long back. And you can see all of these things, and a strong commitment is very, very important. So I attribute, National College to Professor Ram Rao. Perhaps you must have all taken things like for granted, but the commitment and the passion that he has, and also Dr. Maya, Dr. Ramakrishna Rao, and of course, I don't have to say about anything about HN because he has been a monumental figure in all of those things. So let's give a big hand for all these people, and including Dr. Maya also, because I happened to see him for a few minutes on, a couple of days back when he was explaining. He's what I call as an entrepreneur. Very scientifically, and he has been able to do so well. All right, so this is about what I wanted to say. So why do we have to study data, big data? So if you look at it, of course, I'm going to only focus on health information technology because that's very relevant right now, because President Obama, I'll also talk about it, has initiated $100 million on neuroscience data because he wants to find why people are depressed. How do we sort of avoid that? So I'll come to that. So if you look at it, in the United States, if you take the healthcare spending account, is about 17% of the US, GDP. So the question that you will see, the other countries also are sort of looking at, what we call as a worldwide digital healthcare data. It is to be about 500 petabytes of information, large amount of data. So the question that comes here is, can we learn from the past to become better in the future from these data? That's the whole idea. That's all the data analytics part of it, what we are talking about. And that's what Wipro is actually sort of doing it. And I think IBM, and I understand from Narayan Murthy, I think Infosys is also sort of playing a lot of interesting role in that. So you can very well imagine how important. So the question that you can also ask is, have you spent enough money? Has it been well spent? So, in India, our strength is in numbers. We have 1.3 billion population. Even if it is 1% brilliant people, we can actually sort of take a lead role in any area. That's what is happening here also. So, the question is, I want to sort of give you a roadmap in the following slide. So, I've given you a motivation. So, you're looking at 500 petabytes of information only in health, and you very well imagine in other areas. So, timeliness and the uniqueness, and also the background, what are the challenges, what has been done from us and other people around the country, and then the impact it can have. So, what do you mean by big data? If I just simply tell you, I have 500 petabytes of information, so what is that I am talking is, we are talking about a large complex data sets. Okay? Now, these data sets, you cannot in principle use the traditional computational algorithms that we have been doing it for the last 30-40 years. Because this data is so big. So you can't use any traditional data processing applications that we've been doing on that. Now, so if you look at it, big data, how do you process the data? And also, we call it as the velocity of the data. What do I mean? The way in which we are accumulating the data at every instant of time is so big. Before long, by the end of my lecture, I will have accumulated another maybe have or 1 big petabytes of information in only 1 hour right at this point. So the velocity of the data that we are accumulating is also important. Now, how do you sort of use this data? How do you sort of explore and manage this large data set? Now, it's not that easy because, see, if you understand, if you want to know more about me, you go to Google and say S Iyengar, you will know the entire history of what I did for the last maybe 40 years. So where is the data coming from? So the Google has a big data server in Washington. The data server, it goes from here all the way to Sajjanrao Circle. So when you are storing all those data set, the storage is one problem. Then you have to cool that. You can, so the cooling of the large data that is being stored is another challenging problem. Then what kind of organization and structure? So there is a large amount of interesting problems that people can look at. So when you say big data, it is not just the size. Size is only one dimension to the whole problem. So what kind of insights I can get from this complex data? So these big data, they are quite noisy, they are very heterogeneous, longitudinal and very voluminous data. So you have already seen the challenges that we are encountering here. So it aims to answer one particular question that has not been previously addressed by either computer scientists, physicists, mathematicians, like how do you sort of extract relevant data that I need? Okay? So the challenges that we have capturing this data, then storing this data, searching this data, sharing this data, and analyzing this data. So, there are 5 major challenges: storing, relevance and all those things. Each one can get a major Nobel Prize in each of these data. So, this is what we really talk about in the context of big data. Now, the next thing is, what is the overall goal of the big data analytics in healthcare? Since my seminar is going to be related to healthcare, I want to sort of focus on healthcare aspects of it. Now, you remember nowadays, in the United States, and I'm sure it's all electronic health records. So you are talking about the genome sequences, hundreds and hundreds of petabytes of information. Behavioral data, one other interesting thing, my third son, who is doing his PhD at Duke University, he's a neuroscientist. Now, right now he's talking to a lot of people at Niemann's, and I understand in India, we don't have more than 300 psychologists. So they are coming up with lots of techniques to address some of these behavioral data for people, and there are a lot of people who have many different types of the mental problems in this country. People have not been realized, but that's important. Then, of course, the public health data. So that's also very, very important. So the question is, you have all of these data, what kind of evidence or insights I can get? But it should be at a cost that we can afford, lower cost. And then, of course, the outcome through smarter decisions. So, if suppose somebody gives you a big data and, if he says, come up with some nice idea. Take for example, the terrorist activity we had on the December 31st, a big bomb blast on Church Road. So the question is, they are looking at all the data right now, and the question, what is the outcome that you are coming up with? So that a smarter decision needs to be made. So what we want to do is to take advantage of this large amount of data, and when we talk about patients, can we provide personalized care to the patient so that it can sort of develop a major healthcare related system. That means a provider, a payer, a patient, and the management of this data. So this is the overall analysis of the big data analytics in healthcare. So there is also this what we call as a translational medicine here. So for example, the innovation is you have the bench, then you have the bedside, the community, and then adoption policy. So this is what we do in the area called bioinformatics. So that means information analysis, all leading to the biological areas, healthcare. Now, the components are imaging informatics. For example, like brain cancer. So how many images that we need to take? What are the places that has been infected with cancer? How do we do that and so on? It is all sort of done by using imaging techniques. Then of course, clinical informatics. So the doctors are nowadays in the United States, they're so good. I mean, they know lots of computer. All that they look at all the images and can precisely say, this is where the problem is. So then, the public health informatics also. So if you look at it, how, for example, bioinformatics, imaging, clinical informatics and public, all of these things are what we call as translational medicine. Now, so this is a very interesting sort of a component which sort of describes a relationship between the biological aspects of computing, then the translational aspects of computing, and then of course all related to the patients. So what are the timely and uniqueness of this? Now, in the United States, there is a penalty for food care. Like for example, hospitalization accounts for more than 30% of these $2 trillion. Remember now there is a problem of Ebola. And the Ebola, it's killing a lot of people in African countries. And there are a couple of them, they traveled and they came to Atlanta, 1 or 2 people died, and it has become a major issue. So the question is, the annual healthcare cost is about $2 trillion. So not only it is expensive, it is potentially very harmful. So that's why Obama is always coming up with an idea that we need to be able to provide healthcare, a good healthcare to everybody in the United States. Now, the Medicare penalizes hospitals that have high rates of readmissions among patients with heart failure, heart attack, and pneumonia. So identifying patients at the risk of readmission can provide efficient resource utilization. So what is that we are talking about here is effectively making predictions is what is very important from this complex hospitalization data. So now it is so uniquely done and everything is so automated and you get it. I know exactly, for example, if I go to a doctor, within no time I will get a report on my ID, all the things that I have and what needs to be done. And it is all sort of like, so there is a lot of medical devices like an iPad, people can use it. So the most interesting thing is in the context of processing large amounts of data. So White House, just about 6 months back, President Obama, he's unveiled a new board, $100 million research initiative designed to revolutionize our understanding of the human brain. See, brain is a very complex information processing system. There is no one single model that one can use for modeling the human brain. So the question is, the brain research through advancing innovative neurotechnology. So it is what is very critical in all aspects. So find new ways to treat, cure, and even prevent brain disorders. There is a lot of data that is available, and there are a lot of institutions. And I think even in India, I am sure there are many institutions, but NIMANS and few places are the only major ones. So what is that we are interested is, our scientists are mapping the human brain to unlock the answers to Alzheimer's diseases. So how do you do that? That means you have large amounts of data that is being collected based on the patients, and they are looking at the molecular level or the genome level, what is it is making them to develop these Alzheimer's diseases? What are the different genome patterns that you see? So all of those things can be studied very efficiently. So advances in big data are very much necessary to analyze this huge amount of information that will be generated and understand the increased thoughts and the emotions, actions and the memories. All of those things are represented in the human brain. So this is a very top order research topic in the United States, and the major agency that it is trying to do is National Science Foundation and National Institute of Health, because they're putting a large amount of money to understand this brain research initiative. So this is something very important. So we are talking about, again, large amounts of data that is very, very critical here. So let's give you some background on this. So if you look at it, there are recalling, if suppose I'm talking about Alzheimer's diseases or dementia, of course, as we get older, we all try to forget things because neural network, the cells doesn't get connected and we don't produce more number of new neurons. So that's but natural. But sometimes if it can happen to younger people, how do they recall? How do they have some kind of memory recall? Or they can look at the face and recognize. So there is a very interesting aspects to all of these big data that is being collected for many of the neuroscience problems. Now, medication. So there's a lot of medication they give and they also see the effect. What does it do in terms of improving the dementia or the Alzheimer's diseases? But again, by studying all in the context of large amount of data. So, one of the things that we have to think about it is what we call as a large-scale healthcare analytic platform. Now, as I said, with all of this big data, what we are really talking about, information extraction. You remember, this is a large amount of data, and how do you sort of extract the information? Now, once you sort of extract the information, the question that comes here is, how do you sort of do the feature selection? See, the feature selection is very, very critical because, as I said, in the large amount of data that we have, let's assume that we've been able to store the data. What insights can we get from these data? So then if suppose I said, I would like to look at the following features in a data. What features are we talking about? I would like to say, for example, like Caucasians coming from Ireland, London, or the people coming from Asian countries. So you sort of identify those kind of features and see what insights you can develop. Now, when you can sort of extract that, the next question is, how do you develop predictive modeling? So the predictive modeling is sort of being done using model discrimination or parameter estimation or some of the various regression analysis on that. Now, remember, the information analysis is all done by using artificial intelligence techniques because our human brain is also an expert system because you make decisions based on some rules that have been embedded during the last 65 years in my life. So that rules have to be incorporated in your data management for many of the healthcare systems. So what we are really talking is the analytic platform. Now let's see how, for example, the information extraction that we are looking. Now, structured information. So, most of the time, the problem we have with many of the big data, they are very unstructured. Unstructured in the sense, it does not have or exhibit any correlation among various data elements in the program. So, the most important thing is, how do you sort of develop a context? So context information is essentially very, very important because context dependent information extraction is one of the most fundamental problem in the large big data analytics, especially for many of the healthcare. So feature selection represents basically on the feature extraction, then the patient representation, it is all done in the context of this. Then the predictive modeling, you have to classify different set of data. Suppose, we have, American blacks. So I can't mix that set of data with the American whites because the genome sequences are different. So we have to be able to isolate and classify data. So there are a lot of data which is available, what are called as pattern classifiers. So these pattern classifiers essentially will give you an overall picture on many of these data. So what are the challenges? So the big data challenges in healthcare. So finding or inferring knowledge from complex heterogeneous data. Then leveraging the patient and data correlations in longitudinal records, that's very important. Understanding the unstructured clinical notes in the right context. So when you go to a doctor nowadays, when you say, okay, I have this problem, he will make a note of it. Then when once you stay with him for about 10 minutes, then you will have told him enough information about what your problem, then he will be able to synthesize the data. That's what the job of what is called as a context. Now, handling large volumes of medical imaging data. Now, nowadays you know that any kind of examination of health data always involves not just the information but imaging data. Any type of, if suppose you say that you have a heart problem, you would like to see how well your heart is structured, whether it is being expanded or enlarged, or whether some part of it is blocked. So it's all done using imaging data. So the data is very heterogeneous. You have contextual information, you have imaging data. So all of those things have to be synthesized to develop useful information. And then you also have what are called as biomarkers. So when you do a blood analysis nowadays, you know that such an extensive analysis they do, a lot of it may be disjointed, but there is a trend that it is showing why the person is feeling that. So analyzing genomic data is computationally intensive. So then a very interesting problem people are nowadays looking is, why is this particular student is very bright? So they would like to see, for example, the genome sequences and the patterns that it is being. So there are a lot of biomarkers can be used to understand the sequence. So the genome sequence data is also a part of the big data to understand the additional layers of complexity that we have in analyzing this information. Now, capturing the patient's behavioral data through several senses. So nowadays, for example, there are, of course our human body also has many sensors. We have many touch sensors and so on. But we also use some external sensors, and those sensors are being used to constantly measure my heart rate, constantly measure the blood glucose level. I mean, it is 24 hours they can measure. So these sensors also provide a large amount of data. So there is a very beautiful study they have done on the behavioral data. Sometimes people do behave in a very different way. Now again, that is being sort of linked to the neural network. So the kind of behavior that a person exhibits is also very important to understand the characteristics and the person's ability to handle complex situations and other things using all of this data. So if you look at it, all of these data that we collect in the context of healthcare are very important, and most of these data, they are very healthcare. So the bottom line is, how do we process this data? The creation of this data, how do you store this data? Then how do you analyze this data? And these are some of the fundamental questions. So there is a lot of literature that exists in health informatics. So there is a very good journal called Journal of Big Data. It has just been started. So big data analytics in healthcare promises potential, and so there is a health information systems turning healthcare challenges into big data opportunities, because that's another thing nowadays. there are many entrepreneurs have come today. Because all that they are trying to say is, look, you give me all the healthcare data, then I am trying to provide a very interesting solution for that. So one example that we are also working jointly with some companies in India is to come up with a healthcare device for old folks. So, you know, the generation in the United States beyond 60 is growing very fast. So the question is, how do you provide a good healthcare system for that? So you need to create a system like this, you know, an app system in such a way, a person who is not feeling well or who is not able to do certain things all by himself, we don't need to send him to an old folks home. So you will have a system like this, he should be able to call a doctor. He should be able to find, you know, whether the prescription that he has given is working, or all sorts of health related information can be connected, not just in the United States but around the globe. So that's the kind of big data that is providing all the opportunities. So the focus now, how to reshape the healthcare system, the inevitable application of big data to healthcare. So our focus now, basically nowadays, is how do you sort of capture this data? How do you store this data? I'm talking about this big data. How do you search this data? And how do you share this data through the cloud with some other people? And analyze the health informative data in large scale. So that is the main theme and the focus that's been going on. So there are a lot of publications, the big data, then the Journal of Bioinformatics, then there are so the whole world is sort of boiling around this big scale data, and which is very critical because, I mean, so this is the time all the companies are getting involved, and especially even in India, because large amount of opportunities that exist to do all these things, as I said, for storing, creation, and all those things. So, what are the kind of topics? So, there are some target journals. If somebody is interested in learning more about, you know, bioinformatics and or bioinformation processing journal, so there is an Asian journal which publishes. So if you do a Google search, you will see enormous amount of data that is being published. Now somebody was asking me, how do I get this data? To get this data is also not that, you know, difficult, because every company, of course, you know, there is a company whose job or her job is to just store data, all sorts of data, health related data. So they sell this data for some money. Of course, you know, there are issues like privacy issue. See, especially when you talk about healthcare data, privacy issue is very, very critical, because in the United States, people can sue the universities or the hospitals if you sort of release the data which is private in nature. So there are a lot of these, you know, areas that can be sort of attacked. Now, if you look at the technically, what is that we have to do today? We have to understand what is the conventional health data informatics we right now have. Suppose if you are planning to start a small company, an entrepreneurship in the area of healthcare system, so you need to find out what are the opportunities that exist in big data health. So the question is, you know, if you are interested in providing data for Alzheimer's diseases, you can collect it, there's a large amount of data, so you can provide information in a very contextual form for people who want to use it. Then, the most of the things that as we computer scientists we want to do is, how do we write algorithms? How do you write software in the context? And this software essentially analyzes the data, captures the data, organizes the data, all of those things. So, there are some overviews of the big data which I've already talked about it, and how do you sort of analyze it, and then there are potential solutions, and then the long term and the... So, to give you a little more technical aspects of it, the adaptive optimization of medical data profiling in cloud environment. See, cloud environment is very common nowadays because storing data in the cloud form is very good. Of course, there are some issues related to health, privacy, that's fine. But the question that comes here is, if I have to come up with some information on the profiling the data for a particular group of people. See, for example, why in some region of the country, why people are very short. So what is the reason? So you collect a large amount of these data and then store it in the cloud. Then there are what are called as path-based software tools that are capable of querying specific medical data with inherent duplication problems. So one of the things that happens when you store this kind of data is to avoid all the duplication, because what happens with the duplication is you are unnecessarily increasing the volume of the data and you are paying to store that volume of the data. So you need to eliminate it. And then of course there is a noise in the data that should be eliminated. And so probe the data in the cloud using linear operators and machine learning algorithms. So there are well-developed machine learning algorithms that are available that can be used for probing the data. So what do I mean by probing the data? So suppose you have a large amount of data, just like what you do in a Google search, you are trying to do a probing. Suppose let's assume S Iyengar. So when you probe, then you get a lot of information. You are not interested in that. You want to know what awards, S Iyengar got last year. So you can sort of do a context probing and go on recovering information whatever you want. And so the next thing is patient similarity. So that's another important, because if I have sort of looked at a group of patients who have Alzheimer's diseases and I have come up with some analysis on the data, I should be able to see and use the same kind of analysis for a different group, provided the data dimensions that we are storing, they are compatible. So a lot of these things can do what is called as patient similarity. So this is what they do, because if for some reason a particular type of medication is being used or a particular patient has done well, the doctors will say, well, I've used this particular thing in my data structuring, and then I cannot, say that use the same kind of medications for you. So if you look at the health informatics data types, so you have structured data, then unstructured clinical notes, medical data, imaging data, and then genetic data. So nowadays, one of the things people nowadays looking at it genetically, you want to make sure that genetically you are good. If there is a disease that somebody has, it can be genetically, it can be inherited also. So genetic data is also a part of large-scale big data. And other data like epidemiology and behavioral data, all of these data comes under large data. So what is the impact? So the big data could save the healthcare industry up to $450 billion. But other things are also very important. One, right living. The patient should take more active steps to improve their health. There is a lot of responsibility on the patients also, because not only on the big data they have, then right care. So depending on a coordinated approach to care in which all caregivers have access to the same information. That's important. Right provider. That's another important. Any professionals who treat patients must have strong performance records and capable of achieving the best outcome. So nowadays, at least in the United States, before somebody goes to a doctor, you know about the doctor, and there's already enough survey has been done. What kind of doctor he is, how many patients has treated, and what has been. So there is a lot of nice statistical survey on that. So right provider is also important, right value, improving value while simultaneously improving the care quality, and right innovation. So one of the most important things we have to learn in all of this big data is to come up with some new approaches to healthcare delivery. So we need to make sure we take advantage of this big data that we have. And so the stakeholders will only benefit from big data if they take a more holistic, patient-centered approach. That's very important. And also to value, one that focuses equality and healthcare spending and treatment outcomes. So that's the most important paradigm that we need to be worrying about on this. So then there's the logistics, we've been working on this, so there's a lot of things one can do. So the conclusion of this talk is basically, so the big data analytics is a very promising right direction, and which is still in infancy, so no problem has been solved so far. Everybody is trying to take advantage of the big data analytics. Healthcare data is a very rich domain. As more and more data is being collected, there will be increasing demand for big data analytics. So nowadays people are making money even by collecting data. So unraveling the big data related complexities, this can certainly help to make right decisions at the right time for patients. That's the bottom line. So data with more complexities will keep evolving the healthcare. So there are more opportunities in the these kind of things. So what I'm trying to give you is basically an overall approach for the health-related data. So there are still a lot of open problems, and people can work on this, and that's why I think some people who are from industries here can certainly take advantage of this big data, which is still in a very infancy directions, and there's a lot of things need to be done on that. Okay, I think I will stop at this point because I think I've been able to provide. So in summary, there are three things that you have to keep in mind. See, you have large amounts of data in terms of petabytes. So the question is, how do you organize it? How do you store it? How do you retract it? How do you extract it with the right context? And how does it sort of make analysis? So there is a series of issues that needs to be resolved. There is nothing like one system which works for all. Suppose if I have a healthcare informatics solution for Alzheimer's disease, that can only work for that because the data that we have used is for that particular content. So there is an ample opportunities to do a lot of important things in the healthcare technology. So I would suggest perhaps, some of you who are in this area should take advantage and make a name for yourself in the next 10 to 15 years. Thank you very much.
Good evening, ladies and gentlemen. It's my privilege and honor to express my sincere thanks to Dr. S Sitarama Iyengar for giving such a wonderful talk on health information technology with data analytics. It has been very informative and interesting talk, sir. On behalf of Bengal Science Forum and all of us here, I propose vote of thanks.